Hi, you guys. I hope you had an awesome winter break. Hopefully you're still enjoying the rest of it. Hopefully you're watching this video on Sunday or just enjoying our last few hours of freedom. I'm actually very tired. I'm 3:45 this morning because I'm in Chicago. I'm actually recording this from my aunt and uncle's house. There's my luggage right there. I haven't even gone upstairs yet. I am in Chicago for 4 days, and I made time for the math video. So before I get my work done here, I wanted to make sure that you guys have your math video ready to go, and I hope you guys are as excited as I am to start the week. I just cannot wait to get back to school and get back into the swing of things. It's been a very funny last few weeks, as you guys know, with all the snow. So I cannot wait to get back with you guys and get back to work. So we're in Module 4. We're getting into Lesson 7 right now. What we're going to be doing is multiplying fractions with whole numbers. We're finding fractional parts of whole numbers, and we're going to support that with tape diagrams. So we're really going to understand conceptually what we're doing. We're going to draw this, all of the expressions using a really clear tape diagram. It's just a rectangle. And we're not going to do just rote memorization of what does it mean to multiply a fraction by a whole number. We are going to go deep and really understand this concept thoroughly because we're worth it. So let's check out some examples here, guys. Hey, mathematicians, let's get into this. It's Lesson 7. So as promised, we're going to be finding fractions of whole numbers. Keep in mind, and so this is kind of the big leap between Lesson 6 and Lesson 7. We're using that x. The x represents multiplication, as you guys well know. Please remember that 2/3 times 18 is equal to 2/3 of 18. Both of these expressions mean the same thing. So now instead of the of, we're looking at the multiplication sign. But just keep in mind, in case you see this word pop up, when you're looking for a fraction of, I have to get out of orange because that is just, I'll do orange and blue since we're in Chicago Bears territory right now. This orange is kind of depressing me. Keep in mind, 2/3 of 18 is really just looking for a fraction of a whole number. And how do you find a fraction of a whole number? Well, you just multiply the fraction times the whole number, or by the whole number. So let's go ahead and evaluate that expression. We are going to draw this expression using a tape diagram. We are going to chop that rectangle or that piece of tape into 3 equal parts because the denominator, after all, is 3. This entire rectangle, and this was kind of stumping you guys on that one day we had school so long ago. Please keep in mind, we're looking for 2/3 of 18. So this entire rectangle, my friends, represents 18. So let's think about this. 1 unit, if I just wanted to find 1 unit, that would be equal to 18. Wow, it's been a while since I've written with this. Divided by 3. 18 divided by 3 would equal 1 unit. Another way we can write 18 divided by 3 is 18 over 3. Remember this? I hope this is kind of coming back to you guys. Most importantly, what is 18 divided by 3? 18 spread across 3 equal parts. That is 6. So let's go ahead and label this fantastic discovery. 18 divided across 3 equal parts is 6. 6 plus 6 plus 6 is 18. But that's not necessarily giving us the final answer. We're looking for 2/3 of 18. Why do I keep on getting that depressing orange? We're looking for 2/3. 2 out of the 3/3. Well, how in the heck am I going to figure that out? Well, all we have to do is 6 plus 6. Oh dear. 6 plus 6, you guys? Yes, is 12. 2/3 of 18, or 2/3 times 18, you guys, is 12. Let's check out. I'm kind of getting you warmed up here. Let's check out a few more that are going to get a little bit more complex. Buds, here is that problem that I promised just a few seconds ago. This is the more complex problem. The reason why this is more complex than the first, I'm just being paranoid, I need to make sure I'm recording, is because this one requires us to read. Okay, let's read this together. A skating rink sold 66 tickets. Of these, 2/3 were children's tickets, and the rest were adult tickets. What total number of adult tickets were sold? Ooh, I like this. Okay, so let's think about this, you guys, and let's organize this into a really clear visual via a tube diagram. Okay, so our whole is 66, right? There were 66 total tickets sold. We're going to chop these 66 tickets. Well, we're going to chop the rectangle up into thirds because the denominator is 3. So let's go ahead and label what we know. 2/3, 2 out of these 3 smaller rectangles, you guys, were kiddos. And then the rest, which you guys can see, is just 1/3 were adults. What total number of adult tickets were sold? So we want to know this magic number right here. Let's think about how we can find that magic number. So 66 is our whole. Let's try to figure out, let's go ahead and figure out what is 1 unit. Well, 1 unit is going to be our whole, which is 66 divided by 3, or 66 over 3. That's going to give us our 1 unit. Yeah, that's as easy. I was looking back and rereading the problem. That's all we have to do. Now we just have to figure out how in the heck are we going to divide 66 evenly across 3 spaces? Well, the answer, my friends, lies in a long division equation. Let's divide 66 by 3. Think about, this is one way to do this. A lot of you are probably going to be able to do this in your head. That is awesome. I love long division because it's just so much darn fun. So I'm just going to do my long division jam here quickly. How many 3's go into 6? I'm just going to look at that one place value at a time. 2. 2 times 3 is 6. 6 minus 6, nothing. 0 smaller than 3? Let's go ahead and bring down that 6. I ask you once again, how many 3's go into 6? 2. 2 times 3, 6. Nothing left over. 66 divided by 3, my friends, 22. I feel like I'm just grabbing, oh, that's much more friendly. 22. 22 adults purchased ice skating tickets. I have 22 in that rectangle and 22 in this rectangle. So 22 adults, how many kids? Well, that's just going to be 22 times 2, or 22 plus 22. I think we can do that horizontally and think, 2 plus 2 is 4, 2 plus 2 is 4. So we had 44 kiddos and 22 adults. Let's just go ahead and check in with our logic and make sure that that is going to add up to a total of 66. 44 plus 22, 66. Beautiful. Everything is well with the world. Let's take a look at a couple more here, guys. Okay, you guys know I love a good baking problem. Chocolate. I'm really hungry. I've not had much to eat today. I'm going to go ahead and insert myself here because I don't think I told you guys this. While we had all those snow days, I did a ton of baking, and I'm feeling really, really good about my baking skills. I baked bread from scratch. I made some chocolate creations, and I'm just really feeling myself in the baking department. Okay, so let's look at this. Mrs. C, that's me, used 16 ounces of dark chocolate while baking. I've not experimented with dark chocolate yet, just for the record. She used 2/5 of the chocolate to make some frosting, yum, and use the rest to make brownies, double yum. How much more chocolate did Mrs. C, or me, use in the brownies than in the frosting? I like this. Okay, let's obviously change our color to brown because we are talking about chocolate. I will be distracted if I use any other color. So this rectangle represents all of the dark chocolate that I used while baking. So this whole rectangle represents our 16 ounces. I'm going to chop our 16 ounces into 5 equal pieces because you guys can see the denominator here is 5. So here we go. 1, 2, 3, 4, 5. Great. And then let's just go ahead and label what we know. I use 2/5 of the chocolate for frosting. Speaking of frosting, my aunt and uncle I'm staying at their house right now, as I told you in the intro, and my aunt is insane for sweets. I have such fond memories of her growing up because she always had the best sweets and treats in her house, and she still has such a sweet tooth. She and I get along very well, so I think she would really like this problem. Also, if you hear some booming voice come from the background, that means they have come home. Right now I'm home alone, and my Uncle Mike will probably say, Megan Marie! It's been a very long time since I've seen them, so they'll be very excited to see me. And that's my first name. As you guys know, Megan, my middle name is Marie, and he always calls me Megan Marie. He is very, very funny. Okay, so I'm going to try to get this done before they come in. Okay, so we have frosting across 2/5, and then the rest, understandably, is used to make the brownies. Yum. How much chocolate did I use in the brownies? Okay. Oh, how much more chocolate did I use in the brownies than the frosting? Great question. What we need to figure out first is how much chocolate do we have in 1 unit? 1 unit, my friends, is going to be equal to 16 divided by 5. Or, as you guys know, we can rewrite any division expression as a fraction, 16/5. So let's go ahead and use some long division here and figure out what is 16 inside divided by 5. Well, 5 goes into 16 3 times. 3 times 5 is 15. And then we're going to have 1 left over. 1 what? 1/5. Okay, so within each of these smaller rectangles, you guys, we have 3 and 1/5. Using our long division over here, we just found that 16 divided by 5 is 3 and 1/5. So I'm going to just go ahead and label our tape diagram with that crucial information before we move on. Okay, so let's think about how much chocolate was used for the frosting. Well, we used 2/5 of the chocolate for the frosting. That's 2 of these rectangles. Let's figure out what is 3 and 1/5 plus 3 and 1/5. Let's go ahead and add up our whole numbers first. 3 plus 3 is 6, last time I checked. And then 1/5 plus 1/5 is going to be 2/5. So the frosting used 6 and 2/5 ounces of dark chocolate, where the brownies used 3/5. Let's go ahead and add this up in our head. 3, let's do the whole numbers first. 3 plus 3 plus 3, 9. 1/5 plus 1/5 plus 1/5 is 3/5. So our brownies used 9 and 3/5 ounces, where our frosting 6 and 2/5. Our final question, you guys, how much more chocolate did I use in the brownies than in the frosting? So that is going to take us back to kind of module 3 territory. We're going to subtract our fractions. Do you want to hear the good news? Good news is that we have common denominators. Awesome. And then we don't even have to do any ungrouping or unbundling, sorry, because we can do 3 minus 2. This is exciting. 9 minus 6, 3. And then 3/5 minus 2/5, very simply 1/5. So I am grateful that we didn't have to do any of that crazy unbundling jazz that we worked on in module 3. We can absolutely do it, but my stomach is grumbling thinking about all this chocolate. So final answer here, you guys, is going to be 3 and 1/5. 5 ounces. Yum. Oh my gosh, we're going on a field trip in this next problem. How exciting. Let's choose a new color. Okay, so let's read. There are 48 students. My goodness, can you imagine having 48 students in one class? I'm sure this is multiple classes, of course. Okay, there are 48 students going on a field trip. Woo-wee. 1/4 are girls. How many boys are going on the trip? Awesome. So, you guys, something that is so important about these problems is that you answer the question that is being proposed to you, not necessarily answering the question that you want to answer. So I think some of us might jump to, oh, they're 1/4 are girls, 3/4 are boys. Hooray, yes, that's totally true. But make sure that we're answering the question that is being asked of us. Before we do that, however, let's go ahead and organize this information. So we have 48 total kids. That means that our tape diagram represents 48 kids. We're going to chop this 48 into fourths because 1/4 has a denominator of, you guessed it, 4. Beautiful. Now let's go ahead and organize the information that we are given in the problem. So we have 48 kids. 1/4 are girls. So then you guys can see the 3/4 are boys. And we want to know how many boys are going on this darn field trip. First, we need to figure out, how many girls are going on the field trip. Girls represent 1 unit. So whatever 1 unit is equal to, that is how many girls we are taking on this field trip. 1 unit, you guys, equals 48 divided by 4, or 48, that's our whole, divided by, or across 4 equal sections. Okay, so let's figure out what our 1 unit is first, you guys. We can do that very quickly using some long division. Some of you might have this answer already, and that is fabulous. Let's see if we have the same one. 4 goes into 4 one time. 1 times 4 is 4. We have nothing left over. Bring down the 8. 4 goes into 8 twice. Awesome. 2 times 4 is 8. And we have nothing left. So, you guys, each unit is 12. 1 unit is 12. So we have 12 girls. We'll have 12 inside this unit, 12 inside this unit, and 12 inside this unit. So if we want to know exactly how many boys are going on this field trip, what we need to do is 12 times 3, because we have 1, 2, 3 rectangles of 12. 12 times 3 very easily is 36. So final answer here, dudes and dudettes, 36 boys going on the field trip. Just to double check to make sure that we are correct there, what we can do is take our whole, which is 48 kids total, take away the girls. We have 12 girls, and then let's make sure that we come up with 36. 8 minus 2 is 6. 4 minus 1 is 3. And what a wonderful day. Cool. Hope this was fun for you guys. If I went too quickly, please think about it. Go back and watch any of the problems that were a little confusing for you over again, or maybe just watch any of the problems over because you miss my voice so much. The secret word, you guys, is where am I recording this video? I am not in Kirkland. I'm not in my hometown. Well, actually, I might be in my hometown. Where am I right now, you guys? That is a secret word that you're going to check in on Monday. I can't wait to see your sweet smiling faces. Enjoy the rest of break, and please come back ready to work. See you Monday, guys.